Hi and welcome back. In this video we're going to be coding our deletion of nodes. Before we do that though, we need a couple more helper methods. We need to be able to find the parent node of a given node, and we also need to be able to find the rightmost node of a branch, so that we can then replace it. So let's code the find parent, which is going to take an int and is going to return a node. Let's code the find parent, and also let's code the find rightmost, which is also going to take, which is now going to take a node and it's going to return another node. So it's going to take a node which is the start of the branch. So looking at this here, if we give it 7, find rightmost will give us 8, because that's the rightmost node in this entire branch. Find parent, if we give it 7, will give us this node. Okay. So let's code these two methods. What we're going to do for find parent is just the same thing we did for find. I'm going to open it here. Go through all the nodes, but instead of checking whether the value we provided is equal to the current node's value, we're going to check the left and the right. So we're going to see if any of the children have this value, and if they do, we're going to return the current node. So for find parent, I'm going to say current node is self.head, and then while current node is not empty, we're going to say if current node left exists and current node left.value is equal to the value, or, and I'm going to put this divide there because in Python that is useful for getting new lines, splitting things into new lines. Current node.right and current node.right.value equal value. If you don't include this, by the way, it just gives you an error because it says, you know, what does this mean? This is not part of the if statement. If you include this, it realizes that what you want is to split this statement here into two lines for readability. So that's why you include that backslash there. So if there is a left node and the value matches, or there is a right node and the value matches, that means we are at the parent because one of the two children have the value we're looking for. So we return current node. And then we're going to just do the same thing as we did in the find. If the value we're looking for is greater than the current node value, we're going to say current node is current node right. And of course, this has to be current node. If the value is less than current node dot value, we're going to say current node equals current node dot left. Now, you may notice that at no point here are we returning the head. We start off at the head, but we check the two children, and we return the head if the children have the value. We never return the head if the head has the value, or indeed, there's no way that we will ever be able to delete the head with this. So what we're going to do is we're going to say if self.head and self.head.value equal value, return self.head. The reason I'm doing this will become clearer as we continue, and indeed as we go into deleting nodes with two children, because if we are looking to delete the head, checking the children isn't going to give us the head. It's only going to give us the head if the children have the value we're looking for, not if the head has the value we're looking for. It'll become clearer soon, I promise. Let's then move on to find rightmost. Find rightmost is a pretty straightforward method here. All that we have to do is starting at this node here, go right until we reach the end. So all we do is we say current node equals node, while current node dot right, current node equals current node dot right. And then at the end, we will return current node. So again, all we're doing is we are saying current node will be its right node until there is nothing at the right. And when there's nothing at the right, we'll just return the current node because that is going to be the rightmost node. Once again, I'll show you the diagram here. What we've got is, let's say we say find rightmost of this branch. What we'll do is we will start at 7, check the rightmost node, the right node, and we'll say, okay, current node is now 8. And then we'll say, is there another right node? No. So we'll return the 8. And that is indeed the largest node in the branch. It's never going to go left, because as soon as you go left, you're no longer the largest node. So we just go right forever until we reach the end. Okay. Let's then get into the delete. We're going to take a value that is going to be an integer and it's going to delete. What we have to take into consideration is that we may have no children, 1 child, or 2 children. So let's first get the toDelete, which is going to be self.find of value, and toDelete parent, which is going to be self-find parent of value. So now we have the one we want to delete and the parent of that one. And then we'll have a couple if statements. If toDelete left and toDelete right, that means we have 2 children. Elif toDelete left or toDelete right, we have one of the two. That means we have 1 child. And finally, no children. Okay. So these are our options. If we have 2 children, we're going to deal with deleting the node here. If we have 1 child, we're going to deal with deleting the node here. And if we have no children, we're going to deal with deleting the node down here. Let's start with no children. You know how to do this already to some extent. And once again, I'll show you the diagram just to make it clear. Let's say we want to delete node 3. Okay, this node has no children. In order to delete node 3, the first thing we have to know is whether node 3 is the left child or the right child. Why? Because what we're going to do is we're going to say 5 has a child which is 3 on the left. Let's make 5's left point to none instead of 3. That means we essentially delete this link there, and Python will delete the 3 for us. So, if toDelete equals toDelete parent dot left, we're going to say toDelete parent dot left is none. Otherwise, if toDelete is equal to toDelete parents dot right, we're going to say toDelete parents dot right is none. And there is a final option, which is now where the other stuff we coded earlier becomes a bit more obvious. It could be that the node we want to delete and its parent left are not the same. It could also be that the node we want to delete and its parents right are not the same. When? Well, let's have a look. Imagine you want to delete the root node. The root node is not its parents left or right because it doesn't have one. Indeed, in this case, toDelete and toDelete parent will be the same. Why? Because toDelete is going to find the root node. toDelete parent is actually also going to give us the root node because we're looking for the head's value. So these two are going to be the same. These if statements are both going to be false, and this is where we'll end up at. The else, where we want to delete the head, all we have to do is say self.head is none. Assuming, of course, the head has no children. This is what this else is doing. If the head has no children, that means the head is the last element in the tree. It means the head has no children, it means this. So all we have to do is set it to none, and then the 6 will get deleted by Python. Okay? If we have a child, it becomes a little bit different. Once again, we have to do the same thing. If toDelete is equal to toDelete's parent left, now we want to say TDP left, toDelete parents left, is equal to, let's go back to our diagram. Let's say we want to delete 5. We have to say that the parent, which is 6, the parent's left must be equal to the child of 5. The child of 5 could be at the left or it could be at the right. We don't know. So what to do? To delete parent left is to delete dot right or to delete dot left. So again, what we've done here is use the OR syntax in Python to say the to delete parents left has to be to deletes right, but if it's none, use to deletes left instead. So that's a pretty handy way of going about it. And again, we do the same thing, but with the right. Finally, there is one last option, which is when to delete parent and to delete are the same. If they are the same, that means that self.head must become the right or the left nodes. That way, we will essentially be replacing one of them. What's happening here is, of course, let me see if I can hide that, move that there, and show it to you like this. Yes, this is a bit better. Assuming we have one child, which is, for example, this branch here. In this case, if to delete is the parent's left, which it is in this case, what we want to do is set the to delete parent, which is 6, left node to be equal to this left node. Okay. By that I mean if this node is at the left of this one. And if this one is at the left of this one, we want to set this left to be either the left or the right, depending on which one is available. Okay. If we wanted to delete, say, 12, we'll check, is 12 the right child of 9? This would be done down here. Is 12 equal to delete parent right? Is it the same one? Is 12 equal to delete parents right? Yes, so we'll set to delete parents right node to be equal to the left or the right of 12. In this case, it'll be 11. Notice how we can do left or right, because we know that 12 only has one child. That's what this if statement here checks. And finally, if you only have one of these branches and you want to delete the root or the head node, that means that to delete and to delete parent are the same, because they're both the head. And if that's the case, all we want to do is say the head is now 5 or whatever was on the right. So we'll essentially be deleting 6. Okay, hopefully this makes a little bit of sense. It's really tricky when you start off to really wrap your head around this. So what I encourage you is to draw these out. Actually, I have a lot of drawings of these mind maps, not mind maps, but of these binary trees beside me as I was planning this section out, because I didn't want to get it wrong. And it is confusing. It's confusing even after you've been at it for many years. So don't feel bad about having to draw this out on paper. It's something that we all do. So I definitely encourage you to do that. The last thing that we've got left is deleting 2 children. We're going to do this in the very next video, just because this one's getting a bit long, and it's going to be a little bit trickier. There's a few if statements that have to go in here. So let's look at this in the very next video. I'll see you there.